Kia ora, Year 12 and Year 11. This is question 5 from the revision sheet we've given you on EWC with the merit and excellence questions to have a go at. So this question is one where you have to find the area of the shaded region, but you have to give it in a particular form, and this is it down here. So we want to find something root 3 minus b times pi. So that tells you right at the start of the question that you don't want to end up with a number like this. Right, so we don't want an exact a rounded number, we want exact values. And the shaded area is going to be what's left over after we've taken a couple of things away. So overall, we've got a rectangle, we're going to find the rectangle area, and then we're going to subtract the area of the triangle and the area of the sector. Now the area of the sector is actually the easiest one to find, so we're going to do that right now. The reason the other two are harder is because I know this is 12 centimetres, but I don't yet know the height of the rectangle, and I don't know this part here of the triangle. So let's get the area of the sector out of the way. This angle here is a bit hard to see on the video, but it's pi on 3 or 60 degrees. So the area of the sector comes from this formula. Right, substituting in here, I get the area is equal to 1/2 times 12 squared times pi on 3. So that equals 144 divided by 6 pi, which gives me 24 pi. So that's good, and we're happy because we already see a number times pi, so we're thinking that might be something coming in my final answer. And that turns out to be correct. So what I want you to do now is to draw out this part on your paper and see if you can figure out either this length or this length. We're going to need both of them. Try using SOHCAHTOA or Pythagoras. Okay, so drawing out what we've got again. Here's my rectangle. I'm sure yours will be beautifully ruled, but this is the 4th time I've tried to make this video without getting interrupted by loud noises from my kids, so excuse the slightly dodgy drawing. So this is 12 centimetres. We don't really care about that side right now. We do care about this side, so this is also 12 centimetres. We're going to put some right angles in because they're important. So we're going to find this side here, which is x, and this side, which is y. Now we know that this angle is pi on 3, which is 60 degrees. So that tells me a couple of things. Because the angles in a rectangle are all right angles, this angle must be 30 degrees. And this one up here must be 60 degrees, so that the angles add up to 180 degrees. Alternatively, you can see alternate angles in parallel lines. We'll let you spot that that one up there is 60. Okay, so if we just split the triangle out now, we're going to try to find y first, and this angle is 30 degrees, and this is 12. So using SOHCAHTOA, we get that y is equal to sine of 30 degrees. Well, sorry, y over 12 is equal to sine 30 degrees. This is the opposite, and this is the hypotenuse. So y is equal to 12 times 1/2, which is 6 centimetres long. So now we've got y. Now we could go and try and get x using trigonometry. To get a nice exact value, we need to be using the special triangles. I'm not going to do a whole lot on those here because the video won't upload if it's more than 15 minutes, and that's been a problem when I try to talk through the special triangles. So if you do want to understand special triangles now, go and watch the level 3 calculus video on special triangles. They're not difficult, they just take a little bit of going through slowly. So the other way that we're going to do it is using Pythagoras Theorem. So we've got 6 here now, and we've got 12 here. I'm going to take a new slide and draw that out more neatly, and you can try working it through on your own. Alright, so here's my triangle, a little bit bigger. Remember, always do nice big diagrams, it'll make life much easier. So Pythagoras' theorem says a squared plus b squared is c squared. We'll call this side a, and this side has got to be c, the hypotenuse. So 6 squared plus b squared is equal to 12 squared. B squared is equal to 144 minus 36, which gives me 108. So that's b squared. Now b is going to be the square root of 108. But remember, my final answer is going to be something with a root 3 in it. So it's not enough here just to go and put that in your calculator. We're going to get an exact value. And to do that, we need to remember a few things about square rooting. So if I can split this 108 into the product of factors, that's going to help me. So I'm going to do 108 is equal to 9 twelfths. That's the same as the square root of 9 times the square root of 12. So that's equal to 3 times root 12. We can just squeeze this in here. Now, I want to end up with a root 3 and I've got a root 12. I can go further simplifying the square root of 12. So here I've got 3 times the square root of 3 times 4, which is 3 times the square root of 4 times the square root of 3. The square root of 4 is 2, so it's 3 times 2, root 3, or 6, root 3. So that's very useful because I can see that I've now got an exact value for that side length. And all of the hard work in this question is now done, but we're going to put it together on one last slide. So here's my triangle, and here's my sector, whoops, just about, close enough, and there's my area that I want to find. So area of rectangle is equal to base times height. Well, that's going to be equal to 12 times my 6 root 3. That gives me 72 root 3 centimetres squared. The area of my sector we already got is equal to 24 pi. The last thing to work out is the area of the triangle, and I can do that using half the base times the height because I've got a perpendicular height. I'd get the same answer if I used half AB sine C, but we'll do it this way here. So we've got half times 6 root 3, and that gives me 18 root 3. So they're the calculations that go in. So finally we get the shaded area, and that equals 72 root 3 minus the area of the triangle, 18 root 3, minus the area of the sector, which is 24 pi, leaving me with 54 root 3 minus 24 pi centimetres squared. And you are asked to give the values of A and B. A is this number here, B is this number here. So A is 54 and B is 24. Right, hope that helped. Thanks very much for watching, and email me if you've got any questions about it.